All right, guys, now we're going to explore hyperbolas. Their equations are going to be very, very similar. In fact, they're almost the same. The only difference is going to be the addition symbol or the subtraction symbol. So with the ellipses, we had x squared over a squared plus y squared over b squared, and we have subtraction here. And then same thing if it's flipped with the a and the b or the x and the y. And then for ellipses, x squared is always in the front usually, and then for hyperbolas, it switches between the two as far as the x and the y. So we're going to get into it. Let's look at the hyperbola. So in a hyperbola, a equals the distance to the vertex, and c equals the distance to the focus, to a focus point. So as you can see for the two graphs, the a squared is always coming first, it looks like, and b squared is always second. Even though x and y switch, a squared is always whichever is attached to whichever one's first. So the distance to the vertex is always going to be whatever's under the first numerator. All right, so below is the graph of x squared over 25 minus y squared is equal to 9. So this is called a horizontal hyperbola because it is more elongated left to right. The transverse axis is 10 units long, and we're going to look at where that is and how they find that. Oh, give me just a second. Turn on my light. All right, so the transverse axis is the distance between vertices. All right, there's nothing really that we can count up and down, but from left to right, I see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, if A is the distance to the vertex from the center, right, if the center is 0, 0, and a squared is equal to 25, then that means a is equal to plus or minus 5, which is shown here. So the distance to the vertices is 5 on the right, 5 on the left. So total distance between the vertices is 10 units. From the center, we go 5 to this vertice. From the center, we go 5 to the left to the other vertice. All right, a foci is at square root, plus or minus the square root of 34. Just looking off the top of my head, I know that 25 plus 9 is going to be 34. So I think our formula is going to be very similar to what it was with the ellipses. If I were just trying to come up with it off the top of my head, it would have to be like a squared plus b squared is equal to c squared. In that case, it'd be 25 plus 9 is equal to c squared. That would mean that 34 is equal to c squared, and that the square root of 34, the plus or minus, is equal to c. And I think that's exactly what we need. And since the x is in the front here, it's going to be in the x coordinate position. Oh, I'll just erase that. We have it written here. All right, so for this one, your vertices, the distance between your vertices, the transverse axis, is always going to be whatever comes first. All right, so we're going to see that in this next one as well. The next graph is of, forgot to go over the equations of asymptotes. So we have 3 over 5. I know that the square root of 9 is 3, and the square root of 5, or 25, is 5. So I am writing that with an arrow that 3 is the square root of the y denominator and 5 is square root of x denominator. Okay, and if you think about like slope is change in y over change in x, so the square root of the y denominator over the square root of x denominator is how we're going to be able to draw our asymptotes. You will want always the positive negative because you're always going to have one that's going a positive way and one that's going negatively. And we're going to work on how to find those here in a little bit. So next is the graph of y squared over 4 minus x squared over 16. So on this one, the x squared was first. X squared over a squared came first. Now it's this one is y squared over a squared. So we're looking at the second type here. This one is going to be a vertical hyperbola. All right, the transverse axis is 4 units long. As you can see, going up and down, we have 1, 2, 3, 4. So we have 2 up and 2 down. And that's where we are looking at this 4. If 4 is equal to a squared, that means a is equal to plus or minus 2. So we go up 2, down 2, and that's our transverse axis. It's 4 units long. Distance between the vertices. The vertices are at 0, 2, and 0, negative 2. All right, and that again comes from where this is under the y, which is why they're in the y coordinate position. So finding the foci would, let's test our theory again. We've got a squared, well, 16, or 4 plus 16 is equal to c squared. So c will equal to the square root of 20, plus or minus. All right, we can pull out a 2, square root of 5 is equal to c, and it would be in the y coordinate position, which is how we're checking and making sure that that's correct. All right, finding the equations of the asymptotes. You always want to simplify. I mean, either way, if you don't simplify, as long as you graph it correctly, when graphing it, you'll still get the exact same slope. You'll still get the same asymptote. All right, we put it as 2 over 4. So we had the square root of the y denominator over the square root of the x denominator. All right, that means square root of 4 over the square root of 16, which is how we got 2 over 4, which is how they got 1/2. And it's always going to be positive, negative again, because you're going to technically be graphing 2 asymptotes each time, the exact one, one going positive and one going the negative direction. All right. And if you don't remember slope, it's like rise over run if you are having a graph. So you'll rise 1 over 2, rise 1 over 2. So you'll go up, over, but you'll also go up, left, and you'll end up going down, right, so you'll go every direction up and down to make sure that you've got 2 lines completed. All right, so we're going to answer a couple of questions. How do the vertices relate to the transverse axis? What is the transverse axis? So again, the transverse axis is distance between the vertices and just to clarify, the vertices are going to be like the most inner points that your coordinates create based off of, well, for these, the square root of a. All right, so that's going to be, well, a is going to be where your vertices are, square root of a squared, sorry. Since we're given a squared, we have to square root it. That's where our vertices come from. How do the vertices relate to the transverse axis? If we add the distance to each vertex from the center, it equals the length of the transverse. And there's a couple different ways to word that, but that's just the most black and white way to say it, in my opinion. All right, using the denominators, how do we find c? And again, that's going to be that a squared plus b squared is equal to c squared. And if you want to write it just in terms of c, you'll have positive or negative square root of a squared plus b squared. All right. How do the equations of the asymptotes relate to a and b? So the equations of the asymptotes are square root of y over the square root of x. And we can't just say it's always going to be b over a, because that's not necessarily true. If it's y over x, in this case, it's a over b, and in this case, it's b over a. So if it's horizontal, then it's b over a, and if it's vertical, then it's a over b. But you can always look at it as square root of the denominator of y over the square root of the denominator of x. All right, just as normal slope is y over x always, you can just kind of think of it the same way. All right, if you were given the vertices and foci, how could we find b and then the equation of the hyperbola? Well, we would probably have to use a squared plus b squared is equal to c squared. If they're giving you c, right, and they give you a, we are left to just find b squared first, which would help, but giving us a, which is the vertices, we can graph it and then go from there. But we would just have to find b in order to create the asymptotes. And that is pretty much exploration of hyperbolas. Now we're going to do a little going over both of them together, kind of compare and contrast.